So today's homework is going to be kind of difficult, at least the math part. So be ready. Um, in order to answer all the questions, you had to be super high level, I think, I feel like. But I want to put you guys to challenge. Um, but right now we're going to start with this chart right here. I sent it on a group chat. Some people have it. So if you need copy down from there. But basically, this is a complete of all the limits it can happen. So first of all, you can find the limit algebraically. So Liam, you're not supposed to plug in on Desmos because yesterday's homework is you had to work out algebraically. You're not gonna have Desmo on my test ever. So you find the answer using Desmos is to check your answer rather than figure out what the answer is. That's the first thing. You plug in the value, you get a limit, you get a value, you're done. Or you get 0 over 0, then you get indeterminate, you got factoring, canceling, you already deal with that yesterday. Complex fraction, you deal with that yesterday. Radical, you deal with that yesterday. Today, you're going to have some challenge questions. So, number 4 is absolute value. Absolute value, I will want you to use definition of absolute value to break the piecewise function. And I'm going to teach you how to solve those problems. Number 5 is squeeze theorem, which is squeeze theorem. And also tomorrow, I'm going to talk about intermediate value theorem. And tomorrow we're going to talk about trig limits. So trig limits is going to be tomorrow. That's going to be a long day because you got to know all your identity and how to make math works. Then you got a Friday is going to get infinite limit. So when you have number over 0, you can go to infinity. Negative infinity does not exist. So that's the green part of it. That's going to be Friday. So here's a Friday. And here's tomorrow. So tomorrow it's going to trig limits. Today we're only going to talk about those two small things. We're not even going to talk about intermediate. Intermediate we'll probably talk on Friday as well. So that's pretty much got everything completed. Any question about this chart? Now, this chart is like a bullet points, but this is better than bullet points because when a math or anything like that, I think flow chart is better than bullet points because flow chart can actually tell you like, this is what you do. If plan A doesn't work, you gotta do a plan B. Plan B doesn't work, you can go plan C. But I feel like the way I kind of design something is usually like in terms of flowchart, and that's a way to easier to think about things. When I was in UF, we did AP chemistry, not chemistry, but chemistry. You had to figure out an unknown and you had to do the flowchart. You had to say, I did this test and this test doesn't work. So you're going to go to plan B. You're going to do a different test and you can eliminate to find out what is it. Are you on Browstar? You trying to tip me? Okay. I don't know if it worked. I haven't tried yet. Somebody did tip me $1 a long time ago. Huh? Oh, really? Yeah. Cool. So, absolute value situation. The limits that deal with absolute value. So we're going to call it absolute value limits. So if we ever have a situation says limits as x approach to 4 at x squared minus 16 over x minus 4. And I'm going to say from the left side, this is the left side. And there is a limits x approach to 4 from the positive side of x squared minus 16 over x minus 4. Hold on, I need absolute value here. I need absolute value here. And this is a positive. Okay, so what's the difference between limit x approaching 4 from the left and 4 from the right? That's approaching 4 from like 3.9, 3.99, and 3.999 is from the left side. From the 4 from the positive side, it's going to be 4.01, 4.001, 4.0001. You approach for the other side. Now, this is question A, this is question B, and question C is limits as x approach 4 of x squared minus 16 over absolute value x minus 4. So you should recognize, in some way they are kind of related. But when you deal with this question, a lot of people just tended to plug in number, which is when they did one-side limit, which is, I think that's bad. But you need to really understand, you need to really appreciate absolute value, because later when you do derivative or when you're doing integrations, if you understand the idea of absolute value just in terms of graphing, it's gonna solve the problem so much easier than before. Okay, so much easier than before. So start this year. Last year I didn't get a chance to talk about absolute value that much, but this year I'm gonna talk about absolute value more because I feel like it's essential for a lot of problems. So if I ever have a graph of absolute value x minus 4, that basically means there was a 4 right here, is the absolute value shifting right. And they are right part of functions like this. And they are the left part of the function. So I'm going to use the purple line to represent this. And they all have a slope of 1 because there's 1x in the front. This side of the function is going to be, obviously, is x minus 4. Because if you trace this down, it's going to be x minus 4, right? But it's only start at x equal to 4 or x greater than 4. Now, what happened with the purple function? What is a purple function? What'd you say, Gator?
The negative one.
Negative what?
Goes towards 4.
No, it won't be negative. No. Armin? I like that, but I dislike that at the same time. I need that you give me a better word, Bernicia. Negative parenthesis x minus 4. I like that better. And I'm going to talk about why I like that better. Because I like that better because a lot of time it's right there. You can cancel out right away. But if you do negative x plus 4, I'm sorry, negative x plus 4, then sometimes you don't get to cancel out. So I'll show you what happened here. So I'm going to do a on here. So a, I have limits as x approach to 4 from the left side. And the x squared minus 16 over absolute value x minus 4, right? So what happened is I'm going to write down limits as x. If I plug in this, it's going to be 0 over 0, so that we know we had to do some type of math. But in this case, we are approaching 4 from the left. So I'm going to factor the top, x plus 4 and x minus 4. And the bottom is going to be negative of x minus 4. Why is the bottom negative x minus 4? Because we're approaching this direction. So I decided to use this function. Now, Armin, this is the reason why I don't want you to do negative x plus 4, because you don't see anything you can cancel if you have that. Now, if you see right now it's something right in front of you, you can just cancel this and you say, oh yeah, that's done. That's just going to be limits as x approach 4 from the left. And that's going to be negative. This negative sign flow up here, x plus 4. And I'm just going to plug in. So that's equal to limits x approach 4 from the left will be negative 4 plus 4. So that's equal to negative 8. So my answer is negative 8 in this case. Is that okay? Now what happened in here, limits as x approach 4 from the right. Now I'm going to choose the x plus 4 and x minus 4 over x minus 4. And so now it's just cancel out, that's equal to 8. So what happened when limits x approach to 4 of x squared minus 16? What do you think that is? No. What happened if you have limit x approach 4 of x squared minus 16 over absolute x minus 4? Why does not exist? They're not equal to each other. See this 8, this is negative 8. They're not equal to. So if they're not equal to, graph is going to look like something like this. Graph is going to be looking like something like this. So it's x squared minus 16 parenthesis divided by x minus 4. It's going to be like this. So from the left, it's -8. From the right, it's +8. They're not equal to each other. The answer does not exist. Okay. Now we're going to talk about the next one. So do you guys remember this graph look like? So y is equal to sine of 1 over x graph. Do you guys remember this? What does the graph look like? And also when limits x approach 0 of sine of 1 over x. It's oscillating between where? -1 and 1. So it's going to be 1 and -1. So it's going to come in here, oscillate. And it's like something like this or something the other way. But we use oscillating so much that I don't know is +1 or -1. So we say this does not exist because of the oscillation. Is that okay? Now, today we're going to ask a question a little bit different. Today we're asking the red one. Today we're going to say that's equal to x sine of 1 over x. What's the difference between this function and previous function? What's the difference between the red function and the black function? What? No. Yes, Kaden?
Is it the x in front of the sign?
X in front of the sign. So now we're going to still looking at this. So this is what you're going to do. This is called squeeze theorem. So it'd be sine of 1 over x. What is sine of 1 over x is between which two values according to the graph? Between which two values? So I'm going to say -1 and 1. Is that okay? So what I'm going to do is I'm going to make this function look like this one. What do I suppose to do? How do I make the sine of 1 over x look like x sine of 1 over x? Huh? Times what? Times x. Good job. So here I'm going to times x here. So that's going to be -x less than x sine of 1 over x less than x, right? I don't know what happened in the middle. So what my interest is, what happened when x approaches 0 of x sine of 1 over x is? Because we know before it's undefined or does not exist. But this case is bounded by those two things, by the -x and +x. So what happened is I can go here, I can say, let's do a x approach 0 of -x. What is that equal to? What do you think they both equal to? Just plug in 0. What happened? 0. So the boundary is 0. The function is within those two boundaries. That makes this one, therefore, limits as x approaches 0 of x sine of 1 over x is equal to what? 0. Because the upper bound is going to go to 0, the bottom bound is going to go to 0, and the functions within those two 0, the answer has to be 0. Now, I got to show you the graph, how cool that graph is. Okay? Wait for me. Wait for me. I promise you it's worth it. Just give me 1 minute. Sine of 1 over x looks like this. We know like this one already. And we're going to say y equal to x. And then say y equal to -x. So now I'm going to get rid of this function. I'm going to say x of sine of 1 over x. So remember they reach 0 still. It's a rich 0. And so this is squeeze theorem for you. You have 2 questions about squeeze theorem. Hopefully you can figure it out. Very cool questions.
I saw it to me today.